Hello everyone, Triple N here, and today is going to be a very quick video on flyback converter design procedure or the calculations that are required for a flyback converter. Now I know this has been done before, and I know that there have been thousands of other videos before me that explain exactly how to do this with all complicated calculations, but they are above 10 minutes long and involve lots of deadly calculations, which I totally want to avoid. I've fallen into the trap many times. It took me a long time to come up with this. Well, technically speaking, the content is not my own. But this is the simplest way on how to design a flyback converter. No nonsense, let's just get straight down to it. First, I'll be pointing with my Adafruit PCB ruler, by the way. So let's get straight down to it. First, you need to know what you want. Always fix the input voltage, the output voltage, and the output current first. Forget about input current for now. It will fall into place very soon. Then use second step. You need to calculate your turns ratio, which is usually V out by V in if the output voltage is greater, or V in by V out if the input voltage is greater. So whichever voltage is greater comes on top, so that you get a nice clean number. Step number 3, this is where things get interesting. You need to calculate your duty cycle regarding frequency. So duty cycle is equal to output voltage bar by output voltage bar plus input voltage. Now output voltage bar is the output voltage into the number of primary turns divided by number of secondary turns. So basically this V out bar is the reflected voltage that is seen across the drain of the transistor. So this is what we are looking for, like I've written. So the reflected voltage divided by reflected voltage plus input voltage should give you a clean number for duty cycle. And step 4, you need to fix your secondary peak current, which will help you determine your input current. Like I said, one of the first steps was to determine the output current. Now how to calculate the output peak current. So the output current, the average output current times 2, because this is a triangle wave. So your average current will be somewhere around here. Multiply that by 2 and divide it by 1 minus your duty cycle, because the discharge of the energy in the transformer core happens during the second half of the cycle where the transistor is turned off. So this is how you determine your I peak. And now the input current, which is the primary current in your transformer, the peak primary current, which is I in equals number of secondary turns into divided by number of primary turns into the output current. I forgot to add that. Sorry, multiply this by the input current, because your current gets divided down in the transformer turns ratio. So this is what you need to calculate the input current. Number 6, now that you have the duty cycle, select an operating frequency. Once you're done doing that, you'll be able to find the on time and the off time, since you've already calculated your duty cycle. Now that you have all the necessary values, you can simply calculate the primary inductance, the input voltage multiplied by the on time divided by the input current. So you've made every single calculation that you'll ever require for a flyback converter. If you don't know where to go from here, I'll link the calculations down in the description below. 2 links which are extremely friendly and accessible, unlike all the other content I have seen on the internet. And this was a 3-minute 45-second video on how to calculate the values for a flyback converter. Thank you for watching.